Well, hello. I'm Spencer from BuidlGuidl. I'm going to be talking about something a little bit different, and it's a project we've been working on called the BuidlGuidl client, which is a super easy way to run your own node at home with one simple command. And fair warning, I'm scheduled for an hour, but I have a feeling we're going to be getting an early lunch, so don't hold that against me. So some basics on nodes. Why nodes? Why do we care? Essentially, nodes are what's forming the backbone of the Ethereum system. That's what allows us to do all this cool new tech, allows us to travel to all these places, call it work. But essentially what a node is it's a computer running a pair of specialized software packages, which are called execution and consensus clients. We'll get into that a little bit more about that real soon here. And nodes are great because each contains a full verified copy of the chain, so it's trustless. You have it right with you. You don't need to take anyone else's word for it. Nodes are responsible for doing the computing, essentially. They're executing transactions and powering smart contract logic. And nodes are also responsible for coordinating between themselves to ensure that we have a good chain integrity and that no one is in control. So real basics about execution clients. These are the programs that are essentially handling computation for the chain. They're the ones doing the transactions and smart contracts. They're responsible for putting together new blocks and applying state transitions. And this is the software that's basically managing Ethereum state, the balances, contracts, storage, logs, all sorts of other cool stuff in the chain. And for developers, they're the way that you can interact with the chain. So you get that through a remote procedural call endpoint. And so there's many execution clients out there. Some of them more popular ones including Geth, Nethermind, Reth, Asus, and Aragon. And then the other half of the paired software package is called the consensus client. And these clients are more responsible for handling the coordination. Coordination both to the execution client, because the consensus client is communicating with the execution client to tell about blocks, state transitions, and state transitions. And then consensus clients are also communicating to other nodes, consensus clients, to ensure that everyone is following the same chain. And optionally, you can set up your consensus client if you have 32 ETH laying around. This is the way that you can stake 32 ETH and earn rewards for performing validator duties, which are basically creating block proposals when your turn's up and attesting to other validators' block proposals. But for the nodes we're talking about here, I guess you'd call that a validator client. Nodes that I'm interested in are non-validating clients. We'll get into that a little bit. They're great though because it requires no pile of ETH, and you still get the benefit of being a good ETH citizen and contributing to the chain, contributing to the integrity, and also get your own RPC endpoint, which is what a lot of us are interested in. And some of the common consensus clients out there are Prism, Teku, Lighthouse, Nimbus, and Grandine. So this brings us to the BuidlGuidl client, which is not the best name because technically this is not a client. It's not that fancy. It's really a Node.js project. It's a wrapper script for running a pair of clients, and it makes it a lot easier to install, configure, run, and monitor your own validating node. There's a small screenshot of this dashboard view you get when you're running your BuidlGuidl client, and I'll pull it up in a second here. But yeah, as far as installing, it's kind of took inspiration from Homebrew, and it installs with a one-line command, which looks at your dependencies, installs those that you need, pulls down the clients, spins everything up. And one of the kind of sticky points of setting up your own node is the startup configurations for these nodes can be a little complex. Guides are a little bit over the place. So when you're doing it for yourself, you sort of get into this thing where you're almost guessing and checking. It looks like it's working, it's not. Go back, resync. So the BuidlGuidl's client comes with pre-configured startup options for the consensus and execution clients. Just a few command line flags you can put in for some common things you'd want to change. But since it's basically a wrapper that's running these two clients, it's easy to get into the project yourself, and you can make any change to the options for the clients that you'd want. You get as weird as you want. So somewhere. I'll show you what the client actually looks like, point out a few things. This is not synced on my computer, but we'll get an idea what you're looking at. So that's pretty nerdy, built with Blessed Config library. And the main things you're getting are both logs of the clients as they're running. There's a pretty handy status box up here, which will tell you if it's syncing, if there's an error, what the current block is. If you turn your node off, it's got to catch back up to the chain. It'll show you that info, your number of peers, and some stats on how your system's doing. So I've already kind of been through this, but benefits of running your own node. You're being a good citizen. You're improving the chain resilience through sharing data with other clients. You get your RPC endpoint, and there's many distributed RPC services that are out there, including Infura, Alchemy. But it's kind of cool to run your own node because you have direct access to the chain, and I really don't think those services are going to be doing anything nefarious, but you get your own trustless, independent verification of the chain and direct access. And if you're making a lot of requests, sometimes those charges can add up. And with your own node, you're not worrying about a per request fee or running into annoying rate limits. And it's got a few charts here showing it's fast, where the leftmost entry on the x-axis is a BG client that I was running on my home network, so I was just going through my router. And ran a couple of different methods through just to show that, yeah, when you got a local node, it's quicker. So some basic requirements for running the BuidlGuidl's client. It's built for Linux or Mac OS, and for nodes, they're not too CPU intensive, so luckily pretty much any modern processor made within the last few years with at least 4 threads is going to get you by. Some extra CPU power is helpful for syncing. It might help you sync a little bit. It can get a little spicy there, but after your node's sunk up, it's no issue there. On the RAM, you want at least 32 gigs. We did some testing with 16, and it worked for a while, and then we'd get random crashes. And RAM's cheap, so just get 32. The drive selection is a little bit more tricky because these clients are doing a lot of reads and writes. So you want to be a little more picky on that. You're going to want an NVMe SSD with at least 2 terabytes. Talk a little bit more about that later. And you'll want to make sure the drive includes a DRAM cache, which helps with speed quite a bit. And there's another kind of tricky thing is there are different architecture levels for different drives, which is basically saying there's different ways they're set up that have to deal with the amount, more or less the amount of data being stored on each flash chip. And so it goes from quad level cell, you're storing 4 levels on each location, and then you go down to triple, multi is 2, single is 1. And the quad level cell architectures are going to be the most budget friendly. You'll see a lot of those out there, but you want to stay away from those. They're not so quick on read or writes, and they tend to degrade a lot faster. As you get down triple, multi, single, the lower you get on the levels, the more expensive. So multi or single level architectures are probably going to be like enterprise and kind of out of reach. So the sweet spot's going to be a triple. And as far as your network, you're going to want to make sure that your data is not being metered, because a sync node will use more than 100 gigs a day, and they're going to use more than that when they're syncing. And so, yeah, the drive selection is very critical, and it can be confusing. But we got some links to some third-party stuff on our client.BuidlGuidl's.com, and there's this SSD selection guide, which is a GitHub gist of a number of users who have reported how different drives work in nodes. So that's a great place to go. I mean, I've got burned before, like reading specs online for some cheaper drives, and it turns out they lied, and they didn't work. So a setup that's been pretty well tested for us, and we have a number of these going, is we're using used to be Intel. I think Intel stopped making these, but we're using Asus NUCs, the 13 Pro version, which are a little older. I think they might be on 15 or so now. But yeah, we're using NUC 13 Pros with i5 processors, so nothing too spicy. Running Ubuntu on there. Just kind of we've got 32 gigs of kind of run-of-the-mill laptop memory, which is working well, and a drive that we kind of settled on is the Acer Predator GM7000, which I was going to put prices up here, but they're fluctuating so much, and they're different for different regions of the world, but it's not super expensive. I should say, though, that Predator drive, there's one that comes with a little kind of graphene heatsink sticker, which fits perfectly in these NUCs. And there's one that comes with a beefy heatsink, and I very much doubt that it's going to fit in these tiny computers. So get the non-heatsink version. And speaking of thermal management, these little computers come in like a tall version, short version. I go again with the tall version. They do better with thermals. So I mentioned before that you want at least a 2 terabyte drive. These clients do use quite a bit of space, and the developers thought about that, and they have a potential way to save on drive space for syncs. And so I got some really basic cartoons here that are supposed to be showing the chain, where the genesis is on the right, the most recent block's on the left. And developers have given you the option of doing what they call an archive sync, which you very basically break down the chain into 2 main components. You call one component the state, which is kind of the big database, which holds balances, nonces, contract storage, bytecode, all sorts of other stuff. And that's the most storage intensive part. And then the other half you could break it down to, we call it the history, which is more like block headers, transactions, receipts, logs, so on. So if you got a big old drive, you could do an archive sync. And these hold the entire state, entire history for the whole chain. So you're going to end up with a large database, but the advantage is that some methods that you're going to hit the RPC with are dependent upon having the state. So all your RPC methods are going to work all the way back through the chain. And if you want to try to save some space, which a lot of node runners do, you can use what's called a Prune sync, which basically you're keeping the full history of the chain, but you're pruning the state after some number of blocks. And a little confusing. Prune syncs have different names depending on the execution client. Like some call it a full sync, some call it snap. It's not really full because you don't have the whole state, but whatever. This way you get a smaller database if you're going to go with the Prune sync, but you're limited to certain RPC methods that if you're going back further in time than you have the state for. And just to illustrate a little bit, client database sizes that for the clients that we're using, mid-November 2025, a Reth pruned sync is going to cost you about 1.2 terabytes. And that'll give you state for back to 10,064 blocks from the most current. And on Reth, that pruned, that sync point is user defined, so you can change that if you'd like. On the Geth side, a prune sync is going to cost you 1.4 terabytes. And on Geth, the prune syncs, the state is more limited. It's available for the last 128 blocks. And then if you're going with the big boys, a Reth archive sync is going to be about 2.6 terabytes, and a Geth archive is much larger. I've seen different numbers, so I said about 15. It's up there. I haven't tried it myself, so I cannot confirm. So yeah, those execution clients are taking up quite a bit of disk space for sure. On the consensus client side, we're looking at 100 to 200 gigabytes, so not nearly as bad. So I kind of showed a list of the clients earlier, and it mentioned that there's a number to choose from, and that's a very good thing, because client diversity is super important. We really don't want a majority of clients to be using, or a majority of nodes using the same clients, because that creates a bottleneck where a problem in one client could compromise the chain. So there's a big push to get more clients out there and get more nodes running a greater diversity. And kind of illustrate where we're at, I pulled these charts from clientdiversity.org, and figuring out what nodes are running what clients is not super straightforward. It's they even say here not 100% accurate, and even on the execution side, they're saying they have 74% confirmed clients, and they're kind of assuming the rest are Geth. But the way the client diversity breaks down right now is Geth's the big player. Geth and Nethermind are the big players on the execution side. Teku is dominating on consensus side, which with Prism and Lighthouse coming in second and third. And right now, the BuidlGuidl's client is set up by default to run Reth on the execution side, and you have the secondary option of running it with Geth, which is the majority client, but it's tried and true. It's the OG. And on the consensus side, you have a choice between Prism and Lighthouse. Some of the basic BG client startup options, flags to choose your two clients. By default, the BG client will do a Prune sync, but if you want to use an archive, slap that in there. You have the option to set your peer discovery ports for both clients, which is important, because you want those to be accessible to other nodes so that they can benefit from that data, especially during their syncs. You have an option to change the directory. It's usually within the BuidlGuild client directory itself, but if you want to run it on a secondary drive or something, you can do that. And handily, there's an update flag, which is great because clients are constantly being updated for improvements and forks. So if you have the BuidlGuild client, all you got to do is pull it from the Git repo and hit it with that update, and it'll uninstall your old clients and install some new ones. And then there is this owner flag. And this is for a little, kind of like a little mini decentralized RPC service that's running based on our BuidlGuild nodes. And we're using the RPC from these distributed nodes to power scaffold ETH apps. And anyone's welcome to opt in to help us out with powering scaffold ETH. All you got to do is set an owner flag, and good to go. And in return, people opted into the RPC will get an ERC20 called BuidlGuild Bread. It's not worth anything, but it's kind of a super complex point system. But that option is there. And as I promised, I'm way under time, so I'll take any questions.
How compatible, well, first, thanks for the talk. How compatible is the BuidlGuild client with other technologies like OVOL or SSB?
I missed the other technologies you said, sorry.
SSB and OVOL for DVT, Distributed Validator Technologies?
Oh, I'm not familiar with that. I don't have a good answer for that, but I'll figure it out.
Yeah, thank you.
Yeah, sorry. Anyone else? No? Well, I think that's it. Get some lunch.